Hey everyone, welcome back to the EduHaven channel. I know it's been a while, so it's really a welcome back for me too. But I came on here because I wanted to post a video on a specific topic that one of my friends suggested they need help with. Um, and what I'm trying to do is do more informal videos like this one because it doesn't look that set up and stuff. But my plan is to get more informal videos so I can actually post in a consistent basis, or at least semi-consistent, with topics that are more like complex or people suggest to me. So feel free to comment. But here we go. Oh, also, I know it's not the usual pizzazz I have, but if you're ready to succeed, let's go. So the topic in question is sign lines. So sign lines is not an actual like concept. It's kind of a way of solving things. It's not an actual mathematical concept. So don't go telling no professors I'm telling you this because I could be put in jail. But in essence, and we have a line, and it just has two different like functions. So and we know that derivatives are itself a function because they're like it's like a machine, a slope producing machine, right? So first, let me go through a simple example. So I have f of x here, f prime of x here, right? And this is usually representing like x's. And so what you're usually trying to find out is when f prime of x, or when the derivative is 0. So let's say we have something simple. Let's do, trying to think. Let's do f of x is equal to x squared plus 2, right? That means the derivative is 2x, right? So now, when would f prime of x be 0? Well, we know 0, obviously. So this would be like 0 right here. And now we have to think a little critically. So imagine, this is not an official limit over here, but imagine if any value before 0, so -1, -2 to negative infinity, what would f prime of x be? Well, we know that it would be negative. So let me change colors real quick so it's a little easier to see. So you put little negatives above it. So this represents that any value when x is any value less than 0, f prime of x will be negative. Now, in the other direction, when any value of x that's greater than 0, well, the derivative will be positive up until positive infinity, and also the negative ways in the negative infinity as well. Now, one important concept that you need to know is that when the derivative is negative, the function is decreasing, right? Because the slope is literally pointing downwards. So this would be decreasing. I'm just going to write DEC. And over here, if the derivative is positive, the function is increasing. So this would be increasing. And at 0, it's neither increasing nor decreasing. So they call this point right here, be careful what you call it, but it's called a critical point. I'll call it a crit point. Don't want to be careful with these abbreviations. All right. So an important concept that you need to understand. So we know the derivative, negative, positive, decreasing, increasing. That's for like the first derivative. It's for all derivatives, but it's mainly for the first one, in between like the first derivative and the actual function that's found. Now, when you get more complex, I gave a really simple example, but when you get more complex, you get multiple critical points. So, I'm just going to use this example that I have on my board, on my notes. Sorry. Here, I gotta be careful. It gives me the all right. So f of x is equal to x cubed minus 3x squared plus 3x minus 1. Now you can pause, take the derivative if you want some practice. If you don't, I'm just going to write it real quick. Sorry. This f prime x 3x squared minus 6x plus 3, right? And we can factor this out, right? Sorry. You can factor it out. But so we have 3x squared minus x plus minus 2x plus 1. So it'd be 3x minus 1 squared, right? So then, darn it, this is another, but I'll explain it real quick. But so right here at x equals 1, the derivative is 0, right? So that means whenever x is greater than 1 towards positive infinity, it will always be positive, because if you plug in, like, let's say I'm just, usually I use dummy values, so let's say a little bit higher, so 2. 2 minus 1 is 1, 1 squared, 1 times 3 is 1 positive. So you don't really care about the value, you just care about like what the sign is. That's why it's called the sign line, by the way. Anything below it, so -2 minus 1 is -3. -3 squared is still positive. So in this case, they're both positive. So how does this work? So we know it's a cubic function, so this means that we can predict that it's gonna the function itself is gonna be increasing. It's gonna be at like it's a critical point, CRPO, and then it's gonna be increasing again. So it's like boom, like that. That's like the derivative 0 there. So now there's a few things that you need to know using this sign line. The first thing is called relative extrema, which is when, like, within a like interval, they give you an interval. Usually they'll give you an interval, and within the interval you have to find where it's the highest point and where's like the lowest points, or it's usually the critical points. So in this case, it's only 1. Let's just pretend. No, I'm gonna erase this real quick. Let's just pretend. So we know this. We would have found this out using like plugging in points. So like between -1 and 1. All right, let's plug in like -1. Between -2 and negative infinity, -3. So you do kind of points like that. Now from this we know it's decreasing, increasing, decreasing from negative infinity to -2. Remember, if you want to write the interval in which it's decreasing, it would be negative infinity to -2. Notice that it's not a bracket because it's 0. I'm not sure, don't quote me on this, but you can write the, I'm sorry, I said bracket, that's parentheses. You can write a bracket here, but don't quote me on that. You can ask your teachers. But I like the parentheses to keep it simple, because like it's not really increasing nor decreasing. But so increasing, decreasing, increasing, decreasing, decreasing, increasing, increasing, right? So now from this we can determine the relative extrema. So how would you know if a critical point, at a critical point there's a relative extrema? Well, if from either side it changes the sign. So let's look at -2 because it's a critical point, because it's either 0. Another type of critical point is when it's undefined. This would be considered a critical point and a stationary point because the derivative is 0. If it's undefined, like if like the function goes straight up, the derivative is technically undefined. Is really undefined. So that's a case where that happens. So from that, so let's see, negative. This would not be relative extrema because what's happening is it's going down, going straight. Of course, this would be like a smooth direction, by the way, and then going down again. So that's not an extrema, because an extrema would be like that or that, right here or right here, right? So that's not a relative extrema. A relative extrema would be like this, from the left or from the negative direction, it's negative, and from the other direction, it's positive. So what that means, it's literally going negative. So then this is the critical point because it's where the derivative is 0. Let me use a different color for that. Critical point is because it's 0, and derivatives are negative and positive. So that's what a relative extrema is. So there are two types of the relative extrema. They can be a relative minimum. So like this point is a minimum because it goes down and goes up. So this point right here, everything's above it. And there's maximum because right here, everything is below it. So if it's negative to positive, think about like slopes. If it's going negative to positive, so like this would be the relative extrema. By the way, this is the undefined one. The limit does not exist here because, you could do that, you could do that. There's too many options. And then a maximum is when it's positive to negative. So let's look at this example. It's going from negative 0 to positive. So the critical point is x equals 1 because the derivative is 0, and which means the function is decreasing to increasing. And if it's decreasing to increasing, it would be a relative minimum. All right. Now, another topic that you probably have to know is global or absolute extrema. Yeah. So usually when you have absolute extrema, they'll give you some interval. So like this question right here, it's the absolute extrema for the function on the interval 1 to 5, and it's bracket, so it means 1 to 5 are included. So what you do is you literally would go by EVT. You would test the critical points found using the sign line, because where the x values would equal the derivative would equal 0, and then you would also test EPs, which are endpoints. So that would be like the ends where like the intervals are, right? Now sometimes they're the same. You don't have to redo it. And then based on what they ask you, they can be like, oh, the maximum. Whatever number here is like the maximum within. So you would find the CPs, the critical points and the endpoints, but you would plug it into the function, the original function, to get the y value. So that would be like, so let's say we have a function like this. This is the absolute maximum. So you would plug in the x value here, and then it would return the value of the function, which is right there, which is greater than, so it's the greatest out of all of them. So therefore, this is the absolute maximum, and this would be the absolute minimum because it's a critical point, and it's the lowest out of all three of the on the function. So let's do a quick little example. We can erase this. And you know what? Just to make you guys used to seeing, because I know when I was in this class, I used to be, I remember we didn't really like it when there was different little letters. So I'm going to put the sign line, and we're going to put h prime of y. We're getting crazy here, right? And then h of y, right? This would be like the y. But yeah. All right. Let me see if I have an example here. All right. This one's a little crazy, all right? All right. So this one, what is it? H of y is equal to cosine y minus cosine squared y. Right? Okay. Now, this is going to be a little bit of practice of derivatives as well. We know the derivative. You can try it out real quick. Pause the video. So we know cosine y, negative sine y. And we can think of this as like cosine y squared. So you can think of it as negative 2 cosine y, then multiply it by the derivative of the inside. So then times negative sine y. So then that would be, so it's negative sine y plus 2 cosine y sine y. Okay. By EVT. This is what I suggest you do on the paper because it's like organized and the grader will understand you. And this is what also my teacher taught me. That's like the most important idea. Test critical points. So we have to find, using the sign line, we have to find that, but then we test endpoints. All right. So test, let me just make sure this is, all right. Test endpoint. So it'd be h of negative pi, which you can calculate that manually. I'm just gonna use my notes because I'm lazy. This would be -2, and this would be -2 as well. So, and then we now test the critical points. Look at what values of y would the derivative be 0. You don't really need sign lines because you can kind of just figure it out. But if you plug in the three numbers, h of negative pi over 3, h of 0, and h of pi over 3, running out of room now. If you plug them in, you get 0 and a quarter each. So it's 0, quarter. Yeah. And so that means that at x equals negative pi over 2 and x equals pi over 3, x equals pi over 3 would be local minimums, or local maximum. Oh my god, absolute maximums, because they're the highest points. And over here, that when x is equal to negative pi or pi, it would be absolute minimums because that's like the lowest numbers you see. So concavity, this is actually based on sign lines. So let me go here. H of x is equal to x cubed minus 3x squared plus 1. That didn't look right. Sorry. Oh, neat freak. All right, so now we know h prime of x is equal to 3x squared minus 6x done, and h double prime. So this is the second derivative. You can keep going. Fun fact about all polynomials: if you take the derivative enough times, it will eventually just come to 0 because eventually all hit constants, right? So 6x minus 6. Now, at what values of x would the second derivative be 0? So let's write h double prime of x, and then down here is, let's write small. Yeah, I'll write small. h of x. So we know at x equals 1, it would be 6 minus 6, which is 0. So I'm going to write in blue so it's easier to differentiate. Get that? Differentiate. My marker just rolled away. So at x equals 1, 0. Now let's try like 2. 12 minus 6, that's positive. So I think forever it would be positive because there's no other values that I think of right now that 6x minus 6 is equal to 0. So, and let's try 0. So 0 times 0, 6 minus 0, 6 times 0 is 0, minus 6 is negative. So now, as we know, when the derivative is positive, the function is increasing, and if the derivative is negative, the function is decreasing. Another important concept that you need to know is the second derivative. If the second derivative is negative, it is concave down. And if the second derivative, the function. So if the second derivative is negative, the function, so h double prime of x is negative. Therefore, h of x is concave down. Now, at when h double prime, second derivative, is positive, the function is concave up. Now, there's a special term for this point right here, x equals 1. This is called a point of inflection. This is when the concavity will change. So if I were to plot this, if I were to graph this, it would literally look like this. It would either look like this or this, because it's passing through the zero axis and it's going from negative to positive. This is H double prime, by the way. And in this, from this example, it would go from positive to negative. So it's changed. Sorry, it's changing concavity. And it's the point of inflection. So that right there. So if they ever ask you how to find it using a graph, now you know. Yeah, and also with the graph, since we're on the topic of graphs, if it's the first derivative, they're asking you to find the points of inflection. You know, let's say we have uh, something let's say something like this. The x values where it crosses the zero are not the point of inflection. These would be critical points. The points of inflection is where the derivative is zero. So right here, this point, and right here, these are the points of inflection. Well, yeah, these are the points of inflection. Now be careful. Let's say, this example, it's concave down, concave up, point of inflection. Let's say if it was plus, so this would mean it was concave up. That means it's going from concave up to concave up. It's still concave up. So that means this is not a point of inflection. So if you get a graph that's like this, and it just barely meets, I know the picture's wrong, but if it just barely meets right here and still goes up, and this is like the second derivative, this is x, then this is not a point of inflection. All right. That is a lot of work. Now you can tell. So now this one, let's say let's do a little practice one with this one. So where is it concave down? Well, it's negative, sorry, the h of x from before, concave d. So it'd be negative infinity, use the what's called the parentheses, because it's not like an actual number, all the way to 1. And I use the parentheses again. You might be able to use the brackets. Don't quote me on that one though. But then concave up. That's 1 to infinity. And that's sine lines for you. So, all right, that seems like everything, or most of it at least. Thanks for watching. I hope you got something out of it. I hope it helped you at least a little bit. And again, not my signature pizzazz, but I hope you succeed.